I coming to you with a very interesting problem posed. It's cybermath. Now, this is what they call a Diophantine. They're just seeking integer solutions. It turns out there's an infinite number of solutions to this, but we're seeking integer solutions. Now, the very first one that's dead on obvious is just by inspection, and that's okay. We can see that if we substitute 0 here and 250 right here, we get the square root of 250, and conversely. All right, so by inspection, we have a couple of solutions. Now, also, this factorization will lead to another pair of solutions. And notice this is kind of I guess we can call it clever. Factor out root x. You could have just as easily factored out root y, which leads to kind of a symmetrical circumstance here. But what I did right here is factor out root x, and you can check out that this root x cancels with that root x. So you have that this statement certainly implies this statement. But notice that square root of 250 is the same as 25 times 10. Or 250 is the same as 25 times 10. Let me write that down. Right here, you can say that the square root of 250, I'll just write it right up here, square root of 250 is equal to 25 times 10, right? But 25 is a perfect square, right? 25 is a perfect square. Now, that is a 25 there, folks. So you can't take the square root of 10 nicely. It's not a perfect square, but 25 is equal to 5 squared. So when you square root the 25, you get this 5 right here, okay? Now, so with that factorization, we can conveniently let root x be, root x be equal to root 10, and that clearly says that x is equal to 10, not much going on there. And now we will equate the 5 with this piece right here. In other words, we root x we equated with root 10 just for convenience, and then also this entire piece right here we set it equal to 5 right down here. Well, we already know that root 5 is equal to 10, and so I mean that we already know this piece right here is 10, and so we get that y is equal to 160 just by inspecting this expression right here. 160 divided by 10 is 16, and the square root of 16 is 4, right? So we get 5. And so that means that 160, 10, and 10, 160 are integer solutions. Because we could have just as easily have factored root y out of this and gotten a similar expression, right? So by symmetry, or just by what I said, we have another pair of solutions, namely 10, 160, and 60, 110. All right, now are there others? Well, notice that just you can write this as 1 root 10 plus 4 root 10. So what we can do right here, let me clear this out. See, this really, another way of looking at this is this would be 1 root 10 plus 5 root 10, and that would also give you this solution. But we can also separate this apart into 2 root 10 plus 3 root 10. All right, that's the next screen here. Again, and we could have done the whole problem this way, actually. But 5 obviously splits into 2 and 3, all right? But root 40 is the same as 4 times 10. Square root of 4 is 2, is where this 2 comes from. 90 is the same as 9 times 10. The square root of 9 is where this 3 comes from. So again, we get another pair of solutions right here. So we had overall, 6 solutions, the 2 by inspection, these 2 that followed from this factorization, and also these 2 right here. And as far as I know, those are the only integer solutions. All right, hope you guys enjoy.